Okay, guys, we would continue with our class where I've actually talked about indices. We've discussed the laws of indices, the basic laws of indices, and that's where we would continue from. And then we solved some simple questions in our last class, okay? So if you still remember vividly, we talked about the multiplication law of indices. You know, the law says that if you have two bases multiplying each other, like you have two bases like this, let's say b times b, and they have different power. Let me even use number. Let's say 2 and you have power 3. According to the law, you pick one of the base, you add the powers. This gives us b raised to power 5 according to the multiplication law of indices. And also talking about division law, we also talked about division law that if you have something like b divided by b, let's say this is 6 and this is 2, they are the same. The law says you pick one and subtract the powers 6 minus 2. That would give us what? B raised to the power of what? 4. Some persons will choose to solve it this way. They kind of bypass this law. They will put B raised to power 6 over turning this division to this division over B raised to power 2. This is equal to B. They will tell you that B raised to power 6 means B times B times B times B times B. How many B now? 1, 2, 3, 4, 5 times B. That is B in 6 places. All over the same thing here, b times b, that is b raised to power 2 is b times b. So they will tell us that this b will cancel this one kill this. So how many b's are we having at the numerator? We have 1, 2, 3, 4. So it means this is equals to, how many b's are we having? B is appearing 4 times, like, right? So we'll have it to be b raised to power 4 because we have 4 b's. After we already cancel out this, cancel this, and this cancel this. So this is the answer. You can see that the answer we got here by applying the law is the same as the answer we got by just doing this normal division. So that is for division law. I'm just doing a quick recap on what we did in our last class in mathematics. We also talked about if you have something like this, we have the power law. Like if you have something like x raised to power 2 all raised to power 3, you know, this x is raised to power 2, I told you that it is the same as using this power to multiply this power. So now be s raised to power 2 times 3, and that gives us s raised to power 6. So we also, I'm just doing a quick recap. This is not what I want to teach you today. I already explained this in our previous lesson. I also told you if you have something like xy raised to the power of 3, it is the same as sharing this power among these bases. So this will now be s raised to power 3 times y raised to power 3. Don't forget. If you still remember, I told you that if you also have something like s raised to power 2 over 3, this is the same as writing it as you open this, it becomes cube root of x. Then this, the numerator of this fraction that is acting as a power of x becomes the power of this x here. These two just make it as the power of x after you open this cube root. This one was here. The same thing if you have this place to be 4. Let's say this is 4. It becomes what? 4th root of x raised to power 2. So you get it. Don't forget. That means if this is equal to this, if I also have this, I can decide to write it as this. Don't forget, please. Then another thing we talked about is this negative index law. That is, if you have x to the power minus 3, it is the same as I told you. This minus can change 1 over. Then this s becomes the numerator. This power, you rest it on x. Something like this. If I have this, I can write it as according to the law of indices, and if I also have this, I can write it as this. Okay, which other one? You go talk about zero law, that anything raised to the power of 0 is equals to 0. 1 million raised to the power 0 is, anything raised to the power 0 is 1. 1 million raised to the power of 0 is 1. 2 billion raised to the power 0. Teacher Hofuji raised to the power 0. Dennis raised to the power of 0 is 1. Jennifer raised to the power of 0 is 1. Elijah raised to the power of 0 is 1. Nifemi raised to the power. I know Nifemi will always be online watching. You have been very active, Nifemi. I'm really commending you. And then this other guy, Assumpta raised to the power 0 is 1. Most of you have really been amazing. Favor, you have always been active, you have always been following. I am assuring you that there's actually a lot you would learn. Okay, just keep following. Please, just, if I did not mention your name, put it at the comment section. Okay, and for those that are just joining us for the first time, this is teacher of teaching you. Yeah, you're not paying for this tutorial. We also have a closed WhatsApp group. Some of you join this from our WhatsApp group. And if you're not on the WhatsApp group and you want to join, just drop your number, okay, so that I can add you to our WhatsApp group. Okay, so you can be getting information on the subject we are doing next, the topic we are doing next, so you can follow. All right, and make sure you also subscribe to this YouTube channel. Thank you very much. Okay, let's continue. Like I said before, we're going to be treating some questions under indices. Okay, so I will just put one question on the board so we'll solve it together. Pay attention, please. I always advise you to get a book and a jotter. Example 1. Okay, so this is the question we are having before us. This is the question we have before us. We are asked to evaluate 625 all raised to the power of minus 1 over 4. All raised to the power of minus 1 over 4 multiplied by 1024. All raised to the power of 1 over 10. So how are we going to simplify the solution? It's very simple. Please pay attention. It's very simple. Solution. Okay. So the first thing we do, remember the negative, we are going to apply the negative index law here. Are you seeing? Or before we apply the negative index law, you see 625. Did you agree with me that it is the same as 5 raised to the power of 4? Yes, 5 raised to the power of 4 is the same as 625. Okay, so instead of writing 625, just change it to 5 raised to the power of 4. A situation whereby you cannot actually raise this value to any power. Okay, like I said, just go straight to apply negative index law. But before we apply negative, I already saw that if you raise 5 to the power of 4, it will give me 625. How did I know? 25 times 25 is 625. Only this 5, only this 25 is the same as 5 raised to the power 2 times. Why this other one is the same as 5 raised to the power of 2? Okay, so if this is 5 raised to the power 2 times 5 raised to the power 2, you know, if I apply my multiplication law of indices here, it becomes 5 raised to the power, pick the powers, add them according to multiplication law of indices. So this is the same as what? 5 raised to the power 4. It means I've been able to break down this 625 to 25 times 25, and from this 25 times 25, I got 5 raised to the power 2 here, 5 raised to the power of 2 here. Okay, I apply multiplication law and I got it. It means the whole of this is the same as this. So for the purpose of this solution, instead of 625, I can write 5 raised to the power of 4. Remember, we still have raised to the power minus 1 over 4 times. Now look at this here, 1024. There's something that will raise to the power. I can raise something to a certain power that will give me 1024. And what is that? 2 raised to the power of 10. If you check it, 2 raised to the power of 10 is the same as 1024. Okay, I already know that 2 raised to the power of 10 is the same as 1024. So instead of writing 1020, why not just write 2 raised to the power of 10 for the purpose of my calculation? I know some of you will now like, okay, what about those that did not know that 2 raised to the power of 10 is 1024? What about those that don't know? First of all, you should know that what we actually need to do is to break this down. So you should ask yourself, which number can I actually raise to a certain power? You ask yourself, which number can I raise to a certain number? If you don't know the number, just the way I'm seeing this number now, I already know that 2 can divide it. If 2 divide 1024, let's say 1024, sorry, let me just bring it here, 1024. Let me use 2 to divide it first of all. Let's break it down. If 2 divides is 10, look at how you divide something like this. Please pay attention. For numbers like this, because I know some of you'll be rushing to calculator now. Say, oh, 1024, we want to divide it by 2, and then you are looking for calculator to divide this. No, you don't need calculator to do this. Just pick 10. 10 divided by 2 will give us 5. Right? Then you are left with 12. 24. 24 divided by 2 will give us 12. That's the answer. It means 1024 divided by 2 will give us 512. Okay, so I can still break this down. 512, if you divide it by 2, again, if you divide it by 2, it gives you what? It gives you what? 5 divided by 2. The way we did this one, 5 divided by 2 will give me 2 remainder 1. Put the 1 here, making 11. 11 divided by 2 will give me 5 remainder 1. Put the remaining 1, making 12. 12 divided by 2 will give me 6. So what does that mean? It means if you divide this number by 4, Because remember I broke it down 2 times. At the first divided by 2, I also divide this one by 2. Okay, and I got this answer. It means if you originally divide this one by 4, that is these 2 you divided at the first time multiplied by these 2, giving you 4. It means if I divide this by 4, it will give me what? This. If you keep breaking it down, you will get to a point where your answer will be 1. And before you get to that point, if you count these 2 you have been dividing with, it will be 10. So it means if you multiply those 2's 2 times 2 times 2, it will be 1024. It will be in 10 places. If you raise 10 to the power of, to the power of 10, it will give you 1024. Please let me not waste time on this. Let's continue what we are solving. Just know that how we got this is by just know that this is the same as this. I don't need to explain this. I believe you understand. Yes, you should understand. Okay. What text? Okay, this one wasn't here before. So what are we going to do next? Remember that power law. What is outside of the power multiplied by what is inside the power. So I have this to be 5 raised to the power 4. 4 times minus 4 will give me minus. Look at it. I am using this power inside now, the bracket, to multiply the power. What you have outside is minus 1 over 4. What you have inside is 4. So minus 1 over 4 times 4 will give us what? First of all, please use this up one to multiply this. Some persons use this to multiply the, and they also use this to multiply this. No, this one is just an whole number, which is 4. Okay, this is a fraction, 1 over 4. This 4, we multiply this up. 4 times minus 1 will give you minus 4. Don't use this 4 to multiply this one again, please. You don't do that in mathematics. This fraction. This is, assuming this one has a denominator too, you would have said 2 times 4 to give you 8. But it does not have any denominator. Since it does not have any, it means the denominator is 1. So 1 times 4, that's where you have your what? Your 4. Multiply by. You will do the same thing here too. This 10 times 1 will give you 10 over 10. So you have this to be equals to, you're having 5 raised to the power of 4 divided by 4 is 1. So you have this to be minus 1 raised to the power minus 1 times 10 divided by 10 is also 1. So you have this to be 2 raised to the power what? 1. Okay. Please, I want to clean this up portion so that you can see. I believe you have already written what is here. If you have not written it, pause the video now and write it. Okay. I want to clean. So we have 5 raised to the power minus 1 times 2 raised to the power 1. This is what we have. I want to apply negative index law here now. Look at it. I told you if you have something like the negative index law, I can change this minus to 1 all over 5 raised to the power of what? This one. And 5 raised to the power 1 is still 5. So there's no need putting that one there. It's still 5 times 2 raised to the power 1 is 2. This is over 1. Okay. Multiply up, multiply down. So you have this to be equal to 2 over what? 5. That is our final answer to that particular question. I want to believe you understand it. Okay. If you understand, put understood at the comment section. Please write it. Your comments matters. Okay. We have the second question before us. We are asked to simplify 4 raised to the power of minus x. This dot means multiply. It means times 16 raised to the power 2x minus 2. Please make sure you are writing 16 raised to the power 2x minus 2 all divide by 4 raised to the power 2x minus 3 times 120. My board is small, so make sure you are writing. At some point, pause and write. After you digest the information, pause the video and write, jot down. Make sure you are following. It's very important. Of course, you know how we usually do it. After this, I will test you. I will give you questions to solve. All right. So make sure you always pause videos and you write. Okay. So let's simplify this. It's very simple solution. I will not write solution, no, because my board is very small. Probably God won't. You want to assist in helping me get a bigger board. You are the one I'm using it for. I will not say no. I will really appreciate. My body is small. It's a big limitation to me. So if probably any of you watching it, sir, I want to help you get a board, send your account number. Let me buy you a bigger board so you can be using to teach us. You are free to do that, okay? But then till then, let's be managing the small one that we have, okay? Okay, how do you do? It's very simple. Just you see these values here. Let's just try and break them down. All right, let's try and break them down. Let's see. 4 raised to the power of minus x times This is 16. Now, see, I already know that 16, 4 raised to power 2 is 16. Okay, 4 raised to the power of 2 is 16. So instead of writing this 16 here, write 4 raised to the power of 2. Remember, before these two, you have these things existing here, these terms. So you will not just throw them away, write them. Open this time, you open a bracket. Put those things outside there, put them inside of the bracket, you close. We are done with that one. I have 4 raised to the power of 2x minus 3 times this 128. Is there anything, let's check, is there anything we can raise to the power of 4 that will give us 128? Is there anything like that? Let's check. 128, if we divide this by 2, it would give us 12 divided by 2 will give us 6. 8 divided by 2 will give us 4. It means 64 divided by 2 will give us what? Would give us 128. The same thing if you reduce this 64 by 2 again, it gives us what? This will give us 6 divided by 2 will give us 3. 4 divided by 2 will give us 2. Right? So it means if you multiply 4, that is this 2 times this 2 gives us 4. If you multiply 4 times 32, it will give us 128. It will give us 128. And if you do this, if you break this one down again, if you break it down, if you divide it by 2 again, it will give us 16. To give us 16. Yes, this divided by 2 to give us 16. That is 16 divided times 2 will give us 32, right? That's why I'm writing it like this. So it means if I multiply 16 times 4 times 2, everything here should give me 128. Okay, and 16 itself is 4 raised to power 2. Okay, times 4 times 2. So it means this is 4, this is 4, right? So this, according to multiplication law of indices, this and this becomes 4 raised to power 3. Picking one and you are adding the base 4 raised to power 3 times 2. I'm doing this breakdown so that those that do not understand would understand. So we have it to be 4 raised to power 3 times 2. It will give us what? 128. Okay, let's just write it here. 4 raised to power, instead of this 128, let us write 4 raised to power 3. 4 raised to power 3 times 2 is the same as this 128 you are seeing here. So in place of 128, I've written it as 4 raised to power 3 times 2. Okay, now if you observe this, they have the same base, right? Or look at it. Let us open this bracket first. Let's open that bracket to be on the safer side, so that we now have 4 raised to power minus s. I'm not touching anything here. Everything here, I have brought it back here. Times. If I open this bracket, that is what is outside of this bracket, I'm using to multiply this, also multiply this. So 2 times 2x will give me 4x. It's serving as a, please don't come and write the 4x here, I beg you. So this is serving as a 2 times 2x will give us 4x. Then 2 times minus 2 give us minus 4. All over. Repeat everything at the denominator. You have 4 raised to power 2x minus 3 times 4 raised to power 3 times 2. Please, I want to clean the nose at the top. Let's make sure you write so that you'll be confused. So this is where I stop in my calculation. I'll start from here again. Now, if you notice, this base and this base, they are the same, and according to the multiplication law of indices, since they are the same, I can pick one and what? Add this power. Pick one of these, add the power. I'm picking one of these, add the power. So I have 4, add the power. Remember, this is minus x. I'm adding this power, minus x plus the whole of this, bracket open, 4x minus 4, bracket close. I am done with the numerator. What about the denominator? What about the denominator? This and this, apart from this now, I'm talking about only this one and this one. This is 4 raised to power 2x minus 3 times 4 raised to power 3. So these bases are the same, but the powers are different. Since the bases are the same, and this is multiplication, what do I do? Applying multiplication law of indices. I pick one of the 4, then I add this power, that is 2x minus 3, the whole of this power plus this 3. So it becomes 2 raised to the power x minus 3. You can see I'm using bracket now because it's not just one term that is here. 2x minus 3 plus 3. Remember I have times 2 here. Don't throw this 2 away. Times 2, and it's not acting as a power. It's a base times 2. Okay, I can clean this now. All right, so I'm dealing with this. Let's open this bracket. Let's clear this bracket so that I have this to be equal to what? If you remove this from here, you have this to be minus x plus this is plus 1. Plus 1 times 4x will give us plus 4x. Plus 1 times minus 4 will give us minus 4. All over the same thing. Clear this bracket. You have this to be 4 is power 2x minus 3 plus 3 times 2. So if you solve this, this becomes what? Minus x plus 4x will give us what? Plus 3x. So you have this to be 4 is power 3x minus 4. 3x minus 4 is not minus 1. I beg you, they are not like terms. You cannot add them. All over. What am I going to do here? The same thing. Add the like terms. So this gives you 4 is power 2x minus 3 plus 3 will give us 0. So it give me plus 0. If you notice, I only added this. I cannot say 2x minus 3. They are not like terms. Why? Because this one is carrying x. This one is not carrying x. So I will only add this and this minus 3. And notice, I didn't just say 3 plus 3. I put minus into consideration. You know, every number has a sign that behind it. So whenever you are performing the operation, you must consider that sign. I didn't just say 3 plus 3. Look at what most persons we do here. Look at it. They will tell you 2x minus, they will not say 3 plus 3, which is 6. Please don't do that. You will fail it too. Please, this is minus 3 plus 3. Minus 3 plus 3. You are owing 3. You have paid 3. You are owing somebody 3 naira. Minus only signifies that you are owing. I'll take my time to break it down because I know that not everybody have this knowledge. Some persons already know it, but some persons are still struggling to know it. Okay, minus 3 means you are owing 3. Okay, probably I now give you 3 naira. What you will do as a good citizen of Nigeria is that 3 that you are owing, you go and pay. So if you pay the 3 naira you are owing, you have nothing again. That's why minus 3 plus 3 is what? 0 plus 0. No need to put it. It's already 0. Forget it. So this is times 2. Put the 2 here. So the next thing we will do now, remember this numerator is division. Or let me write it like this. This is equals to, let me just move this place so that I will not be confused. This is equals to 4 raised to the power of 3x minus 4 all over 4 raised to the power 2x times, I can put times 1 here because I have this denominator. There's no other numerator that looks like this, so I can put 1. Okay, so this is my 1 over 2. I write it as 1 over 2. I want to clean up now. Okay, then I will leave this. Let's continue. Let me leave this one. This is our next. Now look at this. This is division. 4 is power 3x minus 4. All divided by 4 is power 2x. This is division. And we are going to apply division law here now. According to division law, what does it say? We pick one of the base. We subtract the power. The whole of this power minus this power. So we have 3x minus 4. All in bracket like this. Minus what? 2x. Remember, we still have divided by what? 2. 2 here. Don't forget. These 2 will always make it. We have not used it. You don't throw it away. Some people say you should throw it away. Don't throw it away. So this is equals to what? Open this bracket. You have this to the 4 is power 3x minus 4 minus 2x. Right? All over what? 2. So this is equals to what? Let's add the like terms. This 3x and the minus 2x, they are like them, so I can do something to them. So it becomes 4 is power 3x minus 2x will give us what? 3x minus 2x will give us 1x, which is xx minus 4 all over 2. All over 2. Can clean this now. Don't need it again. Already use it. So Am I going to leave my answer like this? No, I cannot leave my answer like this. Did you know why? I know I can still simplify this. I'm seeing 2 at the denominator. This is 4. There's something I can raise to the power of 2 that will give me 4, which is 2 raised to the power of 2 is 4. So instead of leaving this 4 here like this, why not raise to the power? Why not say 2 raised to the power 2? 2 raised to the power 2 is 4. That is 2 times 2, right? It's 4. So in place of this 4, put 2 times 2 so that I will have a common base at the denominator and numerator. So this is equal to what? 2 raised to the power 2. Remember, I still have this power here. X minus what? 4. All divided by what? 2, which is this one here before. So the whole of this is equals to, open this bracket. You open this bracket, you have it to be 2 raised to power 2x minus what? That is 2 times this, which is 2s, and 2 times minus what gives us minus 8 all over what? 2. Okay, this is what I have. I want to clean this. Let me go clean from ESF. Don't have anything to do. You already know that our topic is indices. So I'm starting from this place now. What do we have? Division law. This and this are the same. Pick one of the base according to division law. This is power 1. Subtract the powers. That is the whole of this power minus this power. So you have this will be 2x minus 8 all minus 1. So this is equals to 2x minus 8 minus 1. This is equals to 2 raised to power 2x minus 8 minus 1. Please, this is not, like I said, don't just bring this minus here, then you now say 8 minus 1 will now give you 7. You will fail it. It's not correct. So what we will do here is we will say minus 8 minus 1. You are owing 8, you are owing 1. You went to buy something for 8 naira, you have not paid. You came the second time. Please, I need sweet. I want to buy it 1 naira. You have not paid. The person said, you are still owing me 8 naira. I said, don't worry, later I will come and pay everything. So that means according to what you are owing 9 naira. 8 minus 8 minus, that is what it means. So that should be minus 9. Minus 9. So this is our answer. 2 raised to power 2x minus what? 9. This is our answer. There's nothing you can do here. You cannot simplify this. They said the question says to simplify. Solve it, break it down. The highest you can do here is to still say 2 raised to power 2x times 2 raised to power minus 9, which is still the same as this. This or this, anywhere you stop. In fact, this one is better. No need for this one, Joe. No need for this one. Just leave it like this. You are good to go. Yes. Look at this other example before us. We are expected to evaluate 0.008 all the way to the power of 1 over 3. We are also expected to evaluate a B 0.25 all raised to the power of minus 2 and C 32 raised to the power 0.2. How are we going to evaluate this? Please pay attention. It's very simple, okay? Like I said, after all of this teaching, of course, you know you have your own work to do for me. So pay attention, pay attention, pay attention, pay attention, pay attention, and jot down, take note of what I am explaining so that by the time you are doing your own work, you can make reference to the notes you have. Okay, so first one, we have 0.008. Please pay attention, a lot will be revealed here. This is question from indices. Now, the first thing that we do here, I'm the one solving this. You see this decimal number here, I will change it to fraction. I will change, and how do you change 0.00? Which fraction would you press your calculator? Ayomide. Which fraction will you Akonde? Which fraction will you press your calculator? That will give you 0.008. How do you do that? How do you change a decimal number to fraction? It's very simple. Look at it. If you have 0.008 decimal, you want to change to fraction. I always tell students, assume that the point is not there. Which figure are you seeing? If you assume that this point is not here, which figure are you seeing? Some persons will say 0008. You are correct. 0008 is the same as 8, irrespective of the number of zeros you have behind it. It is still 8. So I have seen 8 if that figure is not, if this point is not there. But in reality, the point is there. We are trying to change to fraction. So since it's 8, you are seeing put over this point, change it to 1. This one 0. This 0. This 0. So it means 8 divided by 1000 will give you 0.008. But you will not leave it like this. Let's try to, break it down. If you break this down, 2 can go here many times. 2 can go here many times. It will give us 2 here 4 times. And if you break this one down, if 2 divide 1000, that will give us 500. 2 can also go 2 here to give you 2 times. 2 here to give us 250. You can also use 2 to divide it again. Just reduce it till you cannot divide 2 here 1. 2 here, 2 into 250 gives us 125. So that means if you press your calculator, 1 divided by 125, it will give you 0.008. Okay, so in place of 0.008, let us put 1 over 125 there. Okay, so I will not write 0.008, I'll put 1 over 125. Instead, I have succeeded in changing this decimal to fraction. Remember, I will still have this power 1 over 3. If you remember when I was explaining loss of indices to you, I made mention of if you have something like this, let's say x divided by x all raised to power, let me say y, let me go for y, all raised to power 2. Right? The both of them can benefit from this power. This is the same as x raised to power 2 divided by y raised to power 2. So I'm going to be applying that law here now. So this gives us 1 raised to power of 1 over 3 divided by 125 raised to power 1 over 3. This is equals to, place anything raised to power 1 is still that thing. Or applying law of indices. Remember I said this becomes what? If you have any fraction, change that fraction to this stuff here. Then this 3 will be here. While the 1 will be inside. All over. This 1 will be inside. Raised to power of 1. See, it's just not this thing. The same thing, you will do the same thing as cube root. This is 3 here, so that becomes cube root of 125 raised to power 1, which is this one. I have explained this talking about laws of indices before. Fraction index law. If you still remember. So this is cube root of 1. Cube root of 1 is still the same as 1 all over. Anything raised to power 1 is still that thing. 125 raised to power 1 is still 125. So no need to put power 1 here. Okay. So cube root of 125 is 5. That is our cube root of 125 is simply what will you multiply by itself 3 times, that will give you 125, and it is only 5. 5 times 5 times 5 is 125. So if they ask you cube root of 125, the answer is 5, because 5 times 5 times 5 is 125. Let me solve this, and we got our answer to be 1 over 5. So the next problem will be solving. I will leave this one. Please solve this one yourself. Solve it yourself and put your answer. Just pause this video now. Solve this and put your answer at the comment section, please. Then let's move ahead to solve this. Okay, let us solve this. To solve this, remember this is fraction. I told you, decimal. Let's change that decimal to fraction. So if you are changing decimal to fraction, we have 32, 0.2. The way I taught you to change decimal to fraction, the way I changed 0.008 to fraction, please, if you change this one to fraction, what is your answer? Put it at the comment section, sharp, before we continue. If you change it, I don't need to explain how I got it again. It will give you, if you do it, it will give you 2 over 10. I told you, assume that you're not seeing this point, you are seeing 2. So change this point to 1, change this other number, next number to 0. So I have to be 2 divided by 10. And 2 divided by 10 is the same as what? 1 over 5. You reduce this. So it means if you press your calculator, 1 divided by 5 will give you 0.2. So in place of 0.2, put 1 over 5 here. 1 over 5. And if you do this, remember 32. 32 is the same as 2 raised to the power of 5. Don't forget. That is, if you multiply 2 by itself 5 times. In 5 places like that. In 5, 2 times 2 times 2 times 2, 1, 2, 3, 4 times 2 is the same as 5 raised to the power 2. This will give you 32. So in place of this 32, you put 2 raised to the power of 5. Then remember there is still 1 over 5 here. You can put like 1 times 1 over 5. So this will now give us 5 times 1. So you have to be 5 raised to the power 5 over, remember this over 1, 5 times 5 will give us what? 5. So that we have the final answer to what? 2 raised to the power 5 divided by 5 is what? 1. 2 raised to the power 1 is still the same as 2. So that's our answer. Like I said before, solve this one and put your answer at the